Welcome back, guys. In today's video we're going to talk about a subject which I think is often either neglected by software testing courses or is left to later stages, which can then cause quite a bit of confusion, especially if you're a beginner and don't have any experience in software testing or development. We're going to talk about SDLC and STLC, which stand for Software Development Lifecycle and Software Testing Lifecycle respectively. In simpler words, we're going to try to understand how software is being produced and how is it being tested. And I think it's important to cover this topic in the early stages of our course because it will give you a much better understanding and much better context later throughout the course when we're talking about software testing specific aspects as part of the overall process. You will just see the bigger picture way better and it will help you with the actual software testing tasks in hand. So let's get right into it. Okay, so SDLC, which as I said stands for Software Development Lifecycle, is just a term for the end-to-end process which takes any software application from being just an idea to an actual live product used by its target audience. Throughout your career journey, you will encounter at least a couple of types of SDLCs, or you will at least hear about them. You will hear about things like Waterfall, Scrum, Kanban, V-model, and there are many more. All you need to know essentially is that these are just processes which all serve the same purpose, and that is to deliver software products to their end users. These SDLC types, these different SDLC types, differ in terms of the approach or order of doing things, but they all share the same high-level list of activities which need to be followed in order to fulfill that goal. So we will go through that list now on an example of pretty much anything you can think of, and then I will share a diagram with you on the screen where we will go through the software-specific terminology. Now, imagine you want to build any product at all, like if it's a table, I don't know, even if you think about the software application, whatever you want really, you would need to have a certain process in place which will realize your idea, which will take you from one end to the other. And usually it would consist of the following steps, unless you come up with something weird of your own, but at least on part of the SDLCs, these steps are shared. You will somehow have to analyze your idea and put a list of requirements together. This will be your first step. So you will need to put a list of requirements which define what the end result should look like and when you will be satisfied. You will be satisfied if these requirements are fulfilled in the end. Then you will need to define some sort of rules and infrastructure in order to help you realize and fulfill those requirements later on when you're implementing or you're building your product. Later on, you would need to basically start building your product as such, so using the infrastructure you have set up. So in terms of infrastructure, like think about it like if you're building a table, for example, you would need to have all of the tools defined, or you would define and put together. Or if you're building a website, you would need to define the technology that will be used, or the environments, the types of environments that are going to be used, so on and so forth. So, okay, so on the third step, you're already building your product. So once you have built your product, then on a fourth step, you would need to verify that whatever you have built corresponds or fulfills the requirements that you have already defined originally. Later on, you would need to somehow deliver your product to its intended end user. So I don't know, if you're building a table again, you would have to find a store where you will place the table and it will be sold to the people that will buy them. If it's a mobile application, you would need to publish it on Apple Store or Google Play Store or another marketplace. If it's a website, you would need to publish it and publish it on your server and make sure that it's available to the general public. And at the very last stage, what you would need to do is make sure that you maintain all of the tools and infrastructure that you have used in order to make sure that you can build more batches of the same product. In case of a table, you can build more tables. In case of software, you can make amendments to it, you can make better versions, more features, etc., etc. This overall wraps up the high-level list of activities that in one way or the other would need to be performed in order to create a process that will help you deliver your idea to your end users. Now let's look at the diagram that I've prepared and to go through the same list of activities but now in software-specific terms. Okay, let's have a look at the picture here and try to compare two of the most common types of SDLC methodologies, Waterfall and Agile. Waterfall might not be as commonly used in most of the companies that you will probably be applying for a job at in future, but at least it's very common for interviewers to ask if you know the difference between Waterfall and Agile SDLC methodologies. Let me just make a couple of notes before we start diving into the differences of these two. Firstly, this is just a high-level outline for both. Our target in this video or this course in general is not to make a guru of project management or SDLC methodologies out of you. That would need to be a subject for a whole other tutorial series, and we might do it, but just not yet. But I will leave some links in the description of the video in case you guys want to get some extra knowledge and if you just want to continue reading on this subject later on at your free time. Secondly, Agile is a quite wide term. There are different types or subtypes, if I may call them so, of Agile STLC methodologies like Kanban, Scrum, feature-driven development, and more. The most common type, and the one that is becoming increasingly popular in the world of software development, is Scrum. When comparing Waterfall to Agile, we will keep Scrum in mind, specifically in the context of this picture, as you are going to most probably encounter it much more than any other type of Agile SDLC. Alright, so if asked what is the main difference between Waterfall and Scrum, the short answer would have to be that Waterfall is a more linear or sequential approach of software development, while Agile is more iterative or incremental. In other words, in a Waterfall SDLC, one phase must finish before the next can start, and at the end of the last phase, your software application becomes ready as a whole. So it's analyzed and designed as a whole, developed as a whole, tested as a whole, so on and so forth. In contrast, in Scrum, every phase is replicated in smaller iterations, and you build finished pieces of functionality increment by increment. So every small phase, which they call a sprint, by the way, in Scrum, contains element of each of the SDLC phases. Important to note that, as I mentioned earlier, software testing lifecycle spans throughout the whole SDLC regardless of its type. We will also look into SDLC phases, STLC phases in a moment. Okay. Now, let's look at the phases of a Waterfall SDLC in more detail. The phases you see here are the core elements of a Waterfall SDLC. It's maybe worth noting that you might encounter slightly different namings here and there for each phase, or the phases would either be merged or, on the contrary, split into more phases. For example, instead of a requirements gathering and analysis, then design phase, you might see just analysis and design phase. However, don't be confused. If you can grasp the idea based on this diagram, you won't have any issues with variations of it, as in the end it's all about the same pretty much. So the first phase is requirements gathering and analysis, or just analysis phase. This is when the high-level scope of your software application is specified. This phase will usually be full of activities such as describing and discussing the business idea and what problem it is intended to solve, basically, analyzing what features will be in scope and which ones will be out of scope, understanding who is the target audience of the software, defining a high-level timeline for the delivery of the software, so on and so forth. Second phase is the design phase. This is when all of the high-level requirements turn into design, business, and technical specifications, which are much more detailed than in the phase before, and which, after being confirmed, will guide the whole team on how exactly the software should be built. For example, what technology stack will be used, what tools will be used for each aspect of the software delivery, what are the security requirements, etc., etc. The list can go on for quite a long time, really. So again, if you want to read some more on this, follow the links in the description. But for this course, just know that this should be enough. Then you have the development or implementation phase. In this phase, as the name suggests, the development team starts to build up the software. Again, don't want to go into too much detail, but just to give you a couple of examples, developers would start building and installing separate software components, integrating them with each other, creating and running unit tests, and more, which, by the way, unit tests is something we will cover briefly in one of the upcoming videos as well. They're basically preparing the software to its next stage, which is testing. So in the testing phase, obviously this is the main subject of this whole course, but just in the context of the SDLC, it's enough for now to say that the goal of the testing phase is to ensure that all of the requirements that have been defined and confirmed during the analysis and design phases have been fulfilled precisely as specified, and that the software as a whole is ready to go live to its intended end users. Now, the next phase is the deployment phase. The goal of this phase is to ensure that after having completed all of the testing of the software system at hand, the final software package or packages are installed on the production servers, or in easier words, it basically goes live to its end users. And lastly, we have the maintenance phase. Again, here, this phase can be split or named differently, like maintenance and support, etc. The aim of this phase is to ensure that the now live application is performing as it should, that the feedback from end users is processed on a regular basis and addressed, and that all of the necessary housekeeping is performed in order to ensure that the software can be updated as necessary in future. For example, if there is an issue reported by an actual end user, the team has all the necessary means to resolve it in time, or simply to have everything prepared for working on the next version of the software. Now, hope that all of this makes sense to you now, and it's become more clear than in the beginning of this video. And now let's talk about Scrum for a bit. Okay, now the approach used in Scrum to structure or manage the artifacts produced by the phases we just went through is quite different. However, still all the phases or steps we just described are present in here. Have a look. Each small circle in this picture represents what they call a sprint in Scrum. A sprint is essentially a collection of some, but not all of the features, which get built up upon one another in a gradual and incremental manner. Nevertheless, for each feature set, you would still need to perform the same activities as we discussed earlier. You'd need to define them, you'd need to design them, develop them, then finally test and deploy them anyways. Some of the main advantages of Scrum and this incremental approach for software delivery are the fact that you get early end-user feedback, where you can basically see if a certain piece of functionality is successful among users before deploying the next, which could be related to it. Ability to change the software much easier and in a shorter turnaround time. Higher productivity, which results from this divide and conquer approach, where you basically split your whole scope of software delivery into smaller chunks. But even all of this in the context of this course is not critically important for you as a beginner tester. What is important for you to take away is that the list of activities that we were just exploring on Waterfall SDLC can be clearly seen also in Scrum as part of each of the individual sprints. So if you have the necessary skills to perform each activity individually, or rather be part of each activity in a tester's role, you can adapt to the differences of various SDLC types as well. Alright, now let's talk about STLC or software testing lifecycle. It is also a process which consists of multiple phases, and it must be a part of any SDLC regardless of its type. STLC starts and ends with SDLC. In other words, for every phase of software development lifecycle, there is a corresponding phase of software testing lifecycle. Now that you know a bit more about software development lifecycle, let's look at this diagram to explore the different phases of the software testing lifecycle and try to map those to SDLC. Alright, in this picture you can see all of the phases of the software testing lifecycle. Let's have a look and see what each of them is and how they map to respective phases of the software development lifecycle. Again, namings might differ slightly just here and there, but in essence this is what it is comprised of. The first phase is the requirements analysis and the requirements testing phase. In this phase, the testers also participate in the definition of the requirements. This, by the way, maps to the requirements gathering and analysis phase of the software development lifecycle. So in this phase, testers participate in the definition of the requirements, and specifically from the standpoint of the testability of those requirements, provide their input. But then also testers are making sure that the requirements do not contain errors in them, which then, if implemented as defined erroneously, can cause to issues after the software goes live. The second phase is the test planning phase. This is usually performed by test managers, especially in large organizations and in large testing teams. But to me, a good software tester must know what a test plan is anyways and should also participate in the creation of it. This phase usually revolves around producing a master test plan which will govern all of the testing activities in the future. Things like the testing scope, schedule, resources, infrastructure, tools and environments, and much more. We will have a dedicated video about the test plan document in future, but this is just enough for you now to get a feeling of what this phase includes. This phase maps to the design phase of the software development lifecycle, so they're usually performed at about the same time. The next phase is the test case development phase, and it usually is performed about the same time as the development phase in the SDLC. During this phase, various test cases or test scenarios are assessed, and document it in order to give a structured nature to the testing activities in future. So instead of just poking around the software to find something that's wrong with it randomly, you would instead predefine and document, to whatever extent possible, various combinations of tests or test scenarios to be performed against the confirmed list of requirements. For example, if you have a password field, which will be coming your way to test in one of your upcoming features, you would have at the very least 3 test cases to be prepared for testing. Like you will have a test case for testing an incorrect input, so you will give it the wrong password and see how the system behaves. A case of inputting a correct password and seeing how it behaves, and then maybe leaving the field blank. There might be some more, and there will be some more, but just to give you the basic understanding here. Then this brings us to the next step, which is the test execution phase. Now, the goal of this phase is simply to execute all of your predefined tests to ensure that, again, to the extent possible, all requirements have been verified and all of the features have been validated as well. The issues with the software are discovered and reported so that developers can fix them. This phase essentially is the testing phase of the SDLC. Then you have the test closure phase. So in this phase, you could also map the test closure phase essentially to the testing phase of the SDLC, as the deployment to production cannot really happen until the test closure phase is complete. But the goal of this phase is to ensure that all of the test activities are concluded and meet the criteria that were defined in the test planning phase. All of the defects or the ones that were specified are resolved, all reports to all stakeholders of the project have been reviewed and confirmed, etc. Again, as mentioned, this test closure phase is a prerequisite for the production deployment to be even allowed. And lastly, we have the test maintenance phase, which maps nicely to the maintenance and support phase of the SDLC. In this phase, the test team basically supports the software in terms of testing after it is already live. And also, just a slight note in here. So there might be a confusion between terms test maintenance and maintenance testing. Essentially, maintenance testing is the same as what I just described. So supporting the testing of the testing side of things for a software after it has gone live during its maintenance and support phase of the SDLC. So for example, in case if an issue is found during production, after the deployment has happened, the tester would need to investigate it, update the test cases where necessary to make sure that the same scenario is not missed the next time, etc. The test team also does their own housekeeping. This is what you would maybe refer to more as test maintenance. You would perform your housekeeping by doing activities like cleaning up unnecessary test data from the test environments. Just don't be confused. This basically means just resetting things to where they were, or reviewing and updating their test cases where needed, preparing process improvements for later stages, etc., etc. And this pretty much wraps up the main list of activities within a software testing lifecycle. We will be doing deep dives into each of these phases or some of these phases as part of separate videos in future. But for now, I hope it all makes sense in terms of the overall process. Alright guys, this brings us to the end of our video. Today you have learned about two of the most common types of SDLC methodologies, Waterfall and Agile, and you have learned about the differences and similarities between them. You have also learned about software testing lifecycle, STLC, and how is it embedded within the SDLC and how different phases of SDLC map to the different phases of STLC. Hope you found this video helpful, and I'll see you next week.